So on this lovely day, we're going to be chatting a lot about our friend. We're going to be talking about lines and angles. So today's going to be quick. There's not crazy amount of parallel lines cut by transversal, alternate, interior angles, or congruent, or anything like that. It's just going to be simply naming. All we're doing is naming and practicing. Okay, so low key. But as we approach a problem like this, you want to assemble a bookcase, but silly you lost. You have the pieces, but you lost the instructions. So how would you write the instructions? What key vocabulario might you need? We can do an explanation here and... Right, so the key things that we're talking about here is number one, we might use the words vertical, we might use the word horizontal, we might say parallel, or we might say relationship between these two, that they are perpendicular, okay? So, and the more specific words you have, the more specific instructions you can give. So, first, by way of introduction, let's just talk about 3 different ways a pair of lines can have relation. All right, homies and homegirls, let's take a gander at parallel lines. Now, first off, parallel lines, do you see parallel right there? Right there? Watch this. Oh, look, they're parallel. In case you ever, hashtag that was awesome, Mr. Swenson. Parallel lines. Now, here's the key about parallel lines. Do they ever intersect? They don't, you're right, but they also have to be on the same plane. On the same plane. 2 lines that never intersect. Notice I say lines, they go on forever and ever and ever, that don't intersect. Okay, and that's an ugly apostrophe. Parallel lines, here would be some examples. So, for example, if I said this line here, and this line here, and remember, we can use this handy-dandy chicken foot symbol to mean parallel. So how do I say it? If this is line L and this is line M, I can say L is parallel to M. Now, I use the slanted lines right here. Most textbooks will use not the slanted lines, but long lines like that. The problem with my handwriting is that this might look too much like an 11 or like an L. So that's why I slant it. Textbooks don't slant it. Okay, so now let's do some non-examples. What would be a non-example of parallel lines? You might say this. You might make it pretty darn close. And you might argue, oh, Swenson, these two don't intersect. You're right, they don't according to your drawing, but what happens? So in this case, we don't draw it, but the arrow means eventually they do intersect. So just because you don't see it now doesn't mean it doesn't happen forever later. So that would be a non-example. It's close, but no cigar. Okay, the next are called skew lines, and this is 3-dimensional. As opposed to being on the same plane, they are 2 lines non-coplanar. 2 non-coplanar, look at all that. 2 non-coplanar lines that never intersect. Intersect. So how do you draw that puppy? It's a little bit more difficult because you have to kind of have a plane here. And if I have one line that's sticking up, kind of like a flagpole, remember dotted lines mean that it's hidden behind. And I have another line here that's lying flat on here. And there's no special symbol for skew. There's no special symbol for skew. So if this is line P and this one is line N, all we simply say is P and N are skew, or P is skew to N. There's no symbol for skew. No clue. Again, these don't intersect, but they're parallel, so that's a non-example, not skew. And the last one, look at that. What should it say? Perpendicular. Perpendicular. Remember, you can abbreviate with an upside-down capital T, and it's any 2 lines that meet at a right angle. perpendicular lines are any two lines that meet at a right angle. Notice I didn't say anything about coplanar, because the moment they meet, they're coplanar. That's a given. So, clearly, you can just draw that guy and that guy. And as long as you have the right angle there, you can say L and M. Bloop, bloop. L is perpendicular to M. And there we go. And it doesn't matter the orientation. It could be up, down. It could be sticking out of the page or whatever. What example would be just anything that looks close but not quite 90. Something like that. Okay, real quick, let's spend some time identifying here to see relationships. So this is where it requires you to erase or draw or highlight or trace out with your pencil. So let's look at the first one, UT and WT. So here's UT, and here's WT. And notice here, they're lines. In the diagram, they're segments, but we're talking about the lines. So even if the lines don't touch now, doesn't mean they won't touch later. But you do have to pay attention. It is safe to assume, one of the few places to assume something, is that when you have a three-dimensional object that looks like a box, it's safe to assume it's a box. What do I mean by that? It's safe to assume these are all right angles. So all these puppies are right angles. Safe to assume that. And then make that prettier. Bloop, bloop, like that. All right. Perpendicular would be a good. Perpendicular would be good. And you can just draw the symbol perpendicular. That's fine in dandruff. Okay, now let's look at RS and VW. RS is back there, and WV is right there. So the two blue, one's in the back corner and one's in the front bottom corner.
Still on the same.
There you go. They're parallel. And you're like, but Swenson, aren't they supposed to be on the same plane? They are on the same plane if you cut a ramp. Notice, if I cut this right here and I make a ramp, this one's at the bottom of the ramp and this one's at the top of the ramp.
How do you get them ever?
How do you get them skewified? Well, let's see. What's TU and WX? What's TU, and WX? This one's on the top, and this one's way on the bottom, but coming out, kind of like coming out of the paper, and this is coming along the paper. So these two are skew. There we go, our first skew. Dun, 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 dun. I bet you. It turns out planes can have the same relationships, but generally planes, there's no such thing as skew planes. No such thing as skew planes. So either they're parallel, perpendicular, or just they meet at some other angle. So looking at the first plane, let's see, VWT. VWT is the plane in the front. And then RSX. RSX is the one in the back that we can't really see. So those puppies would be parallel. Comment? All right, now on page 2, this is where we get to the meat of taking us to the next level in chapter 3. So your friend and mine for the next week and a half will be this word called transversal. Transversal. Okay? If you were to word dissect this, trans means to go over something, and verse actually means line, right? The verse of a song, right? Aren't those lines of a song? Verses of a poem, lines of a poem. So a transversal is a line that goes over other lines, okay? So here's the transversal that's going over these two lines. The transversal is crossing over those two lines. Now, just to give you a heads up, a transversal can also be transversed. What? Let's take a gander here. You do not need to draw this. Relative, if I'm talking about this one, then that's the transversal of this line and this line. But if I'm talking about the black line is the transversal of these two red lines. Or I could say that this red one here is the transversal of those two lines. So you have to pay very close attention to which one is called the transversal, and that from there. So if this is the transversal, then I need to focus all my attention here and effectively ignore ignore stuff over here. So I would have to ignore all this stuff right here. Question? All right, I know corduroy, we get you all excited. So here's what happens when lines are formed. So take a gander. I called that transversal, and I'm intentionally messing up things here. So I'm saying 1, 2, 3, and 4. And I'm calling these ones down here 5, 6, 7, and 8. I intentionally did a different pattern up there and there, so you don't get stuck with the numbers. So please copy down exactly as you see. 1, 2 going down, then 3. So I went counterclockwise this way, clockwise this way. So if I were to ignore, just temporarily, ignore the bottom, notice that all these have relationships. So think of this as your immediate family, right? You've got vertical angles, we've got linear pair, linear pair, linear pair, linear pair, right? So these all have relationships within this context, just like in your immediate family, you have brothers, sisters, moms, and dads, right? Okay, now think of this as extended family. Down here and up here, this guy has a relationship to this family, right? Just like you have a relationship down here with your cousin, right? Because I'm a child of a brother, and he's a child of that brother. So we are now cousins. All right, so we already know the relationship between these four here and the relationship between these four here. 5 and 7 are vertical, 6 and 7, etc. are linear. So what we want to now do is see, how does 4 relate to 6? How does 4 relate to 8? How does 1 relate to 6, etc.? Now, some there's a direct relationship, and some there isn't. So we'll look at a good chunk of the relationships. All right, so here's what corresponding means. Corresponding means the same relative position. Same relative position. When I say relative position, I say, oh, this one's on the top left. So look up here. Angle 1 is on the top left. In this family, angle 1 is the top left. So what's the top left down here? 5. So 1 and 5 are corresponding. 4, top right. What's the top right down here? 6. So that's how we do corresponding. And why did I say positive? No clue. Position. All right, so angle 1 and angle 5 are corresponding angles. Another pair, angle, what did I say, 4 and angle 6. Good. Turns out there's even more pairs than that. Next up, we have alternate interior, exterior, alternate interior, consecutive interior, and you're like, what the? Alternate just means to switch, right? This means to switch. And exterior means outside. Outside what? Well, let's think. If we are considering the two lines, this out here, this would be the inside, right? So what are the 4 angles that are inside between the two lines? Well, 2, 3, 5, and 6 are inside. We call that the interior. Which means 1 and 4, 8 and 6 are outside. So we call this the exterior, and we call these the exterior. Why? Because it's relative to the two original lines. They're between, these ones are outside. So interior versus the exterior there. So angle 1 is exterior. So what does the alternate switch sides down here, but also exterior? So 1 connects to 7. Notice I'm switching sides, but these already have a relationship, so I'm not going to say another name. 1 and 4, they're linear pair. So 1 and 7 are alternate because they alternate sides, and they're exterior because they're outside this. So 1 and 7 here. Angle 1 and angle 7. So what's the other pair? Please tell your name. Good, so 4 and 8 are the other pair. Angle 4 and angle 8. So the definition I already wrote effectively by using this here. We switch sides and they're outside the two lines. So by default, as we read this, alternate interior angles would be anything on the inside. Say, for example, number 2, it alternates sides, but it's also inside. 2 and 3 already have a relationship, so now it's 2 and 6. So 2, 6, 3, 5 would work here.